Okay, I'm going to present my work about profiling NVIDIA Jetson embedded GPU devices for autonomous machines. NVIDIA Jetson GPUs are one of the most popular GPUs used for embedded devices. And the left picture is Jetson TX2, which is the GPU we'll use today. And the right picture is F110 race car with Jetson TX2 on it. And this is the hardware platform we use. And this is the architecture of Jetson TX2. Yeah, as you can see, these are two Denver CPUs and 4 Cortex CPU. And here is the GPU passcode of Jetson TX2, and it has 2 streaming multiprocessors, each with 128 CUDA cores. And first, I want to introduce some basic knowledge about CUDA programming. In CUDA programming, this is a kernel function, and we can specify the number, and the whole program will run on a grid, and each grid has many blocks, and each block has many threads, and each function will run on one thread, so those functions will run together, and that's why the GPU can support the simultaneous programming. This is the GPU architecture. As you can see, it has many streaming multiprocessors, and a streaming multiprocessor has many CUDA cores in it, and each function will be put into one CUDA core, and so the program can run in parallel. And this is Jetson TX2's working modes. It has 5 working modes, and these modes are a trade-off of the power consumption and the efficiency. As you can see in mode 0, both 2 Denver CPU cores and 4 ARM cores are used, and the GPU frequency is the highest. And so the mode 0 has the highest performance, and the mode 4 only use 1 Denver CPU core and 1 ARM core, and the GPU frequency is also lower, so it may support better power consumption working. And here we discovered 2 tools to profile the performance of the programs on Jetson devices. The first tool is called tegrastats, and the Jetson stats is visualization. Tegrastats is only a command line to run, and this is its output. And you can see it's difficult to read, so we can visualize the output by Jetson stats. And in the output of Jetson stats, you can see the left picture is the working mode 2, and all the 6 CPUs are used, and the right picture is mode 4. Only 2 CPUs are used. So we can gain some knowledge about the state of the current GPU's working state. And the second tool is called Nsight System. It is a tool to run on host computers and profile Jetson devices through SSH connection. This is the looking of the software, And you can right-click the project and configure targets to connect to your devices. So we'll use some examples to explain how this tool work. The first example is a vector add program, and it's a classic CUDA programming example. And in this example, we initialize the vectors on CPU, and there's no data prefetch from the CPU to GPU. So as you can see, this is the timelines of our function add vectors into. This add vectors into is our kernel function. The kernel function is a function of the CUDA programming. And here is the memory prefetch, and it has H2D transfer and D2H transfer. And this green one is the H2D transfer, and the maybe purple one is the D2H transfer. So you can see when the add vector infos is running, and all the time it has the memory transfer from from CPU to GPU. So it will cause many page faults, and the performance will not be very good. And if we prefetch the data from the host to device, and this is the function in the last slide, and you can see its working time is much shorter. And this is the, it will prefetch the data first and then begin to run the kernel function. So its total performance is also better. And if we initialize the data directly if we need if we initialize the data directly on CPU, and you can see there will be no data transfer from CPU to GPU, and so the performance is the best. And in the last slide, the total runtime is 900 ms, and now it is 400 ms. So we can have an insight to what is happening in the GPU device. And here we use some examples to really profile the running time of our codes on GPU, Jetson GPUs. So in CUDA programming, we can specify the number of threads per block and number of blocks per grid. And we still use that vector add example as our first example. And when there are 32 threads per block and 2 blocks per grid, the runtime is 240. And in other configurations, the running time is much shorter. And also without GPU, the running time use 49 seconds. So you can see when the configuration is not good, the running time may be higher. And this is because of the data transferring from GPU to CPU or from CPU to GPU. So this cost much more time than even if we don't use GPU at all. And the criteria to choose the best number of threads per block and the number of blocks per grid is that the time of these two numbers should be should be a multiple of the maximum number of warps supported on a streaming multiprocessor of GPU. And another example we use is the particle filter. This is a recasting method to use, and it will generate many points in the road, and the car will follow these points to finish its autonomous driving. And the left one is the situation when we use GPU, and the right one is the situation when we don't use GPU. And when we use GPU, you can see the points are denser. This means it will generate these points faster. And in this picture, you also can see its performance much aligned with what we show in the parameters of the 5 working modes of Jetson TX2. As we mentioned before, the mode 0 has the highest performance, so its speed is the fastest, and in mode 4, the speed is the slowest. And as to the power, the mode 0 consumes the highest power, and the mode 4 consumes much less power. And RM, CDDT, and RM GPU are just 3 algorithms to run the recasting method. And I think that's all of my presentation. Thank you. Do you have any questions?